y'all, it's Maddie. Welcome back to my channel, and welcome to part 3 of this metabolism series, the final part. Today I'm going to be showing you how our bodies can use proteins for energy and metabolism, and kind of how all that works. If you didn't see parts 1 and 2, feel free to go check those out. Those were the other 2 videos I posted this week. The first one was on carbohydrate metabolism, and the second one was on fat or lipid metabolism. So let's go right ahead and jump into part 3. So remember, our ultimate goal is to what? Make ATP. But in order to get there, we have to go through a process. So proteins are made up of amino acids. As a matter of fact, insulin is a protein made up of different amino acids. Now, amino acids can vary depending on what they are. But your body, if absolutely necessary, will use protein for metabolism and for energy. Now, proteins can look kind of differently. Some of them are spiraled, some are folded on top of another. It depends. And they are composed of carbons, hydrogens, oxygens, nitrogens, along with an amino acid side chain. This is your very last resort that your body will use for energy. It will first do carbohydrates, then fats, and then at a very last resort, it will break down your own protein, which is mainly found in your muscle mass, which isn't healthy. And this is something that I went through in DKA. You can tell this through your urine. If you are spilling a lot of protein in your urine, good chance that your body is actually using protein for energy. Mainly what we use protein for in the foods that we consume. The protein that we use, if you read a label, it says it has 12 grams of protein. Proteins that we use, we actually break down into amino acids and arrange them in different orders for us to be able to rebuild our own DNA and our muscle mass. DNA stands for deoxyribose nucleic acid, and that is what comprises of our genes. So that is mainly what protein is used for in our body. But now I'm going to explain what can happen when you use protein for energy. Now, for those of you that have type 1 diabetes, and know that if you have a very heavy protein meal, it actually can get converted into sugar, also through gluconeogenesis. Now, this happens much slower than carbs. So you'll notice if you had like a very heavy protein meal, like say lots of meat, or a very protein-based vegetable, or very protein-based food without a lot of carbohydrate, you may notice that you need insulin, but you may need insulin after your meal, or maybe like 20 minutes after eating your meal or something, or you're not going to need a lot of insulin to cover for that. Now, Dr. Bernstein is a classic example of using a lot of heavy protein to cover for insulin. Basically, he comprises his diet of 6 grams of carbohydrate at breakfast, 12 at lunch, and 12 at dinner. And he boluses with regular human insulin to not only cover for those minimal amounts of carbohydrate, he's actually covering for the amount of ounces or grams of protein that he's consuming with human insulin. And regular human insulin better mirrors the digestion of protein. Again, I'll dig into that later when I share kind of what I've been learning from Dr. Bernstein. But anyways, let's get into how your protein is broken down into energy if absolutely necessary. So you have protein. There's actually a nitrogen pool. Proteins have to be comprised of a lot of nitrogen atoms because of the amino acid chains. So you can, most of the time your body is going to take the protein from your tissue. Your tissue protein like your muscles. Now, this is something I noticed, like I said, when I was in DKA. I noticed my arms and my legs were shrinking. And particularly for my body, prior to me being diagnosed with type 1 diabetes, I did not have a lot of fat on my arms or my legs. Now, obviously, there's going to be some, but there definitely wasn't a lot. And to watch my calves and my upper arms particularly wither away kind of scared me. And it was probably because my body was in that last stage of resort, breaking down protein for energy if absolutely necessary. But this is very hard on your kidneys. This is hard on your body. And it can be kind of painful, actually. That'd be part of the reason why I didn't feel good either, or like to rest it hurt, to lay down it hurt. It's kind of a crazy thing. So it's going to go through this process called the urea cycle, which in itself is very complicated. Instead of your body using the citric acid cycle and the electron transport chain, your body will go right through the urea cycle, which again is very hard on your kidneys. and it often results in protein being spilled in your kidneys, which isn't good. Can damage the microvascular regions of your kidneys, the glomerular filtration units, and cause kidney damage. You can also take the nitrogen pool, and you can also break protein down through pyruvic acid and lactic acid cycle, or it can go through acetyl-CoA, and then from acetyl-CoA get turned into a fat store, or as a very, very last resort, you can do the citric acid cycle and the electron transport chain. But I'd say primarily when you think of and see proteins being broken down for actual metabolism, it's the urea cycle that's going to go first. And because that's the quickest way your body can break those proteins down into something that your body can use for energy. Because remember, the ultimate goal is ATP. And no matter what you need to do, and no matter how excruciating it is on your body, if your body needs to break down your muscle mass for energy, it will. This can also happen not only in DKA because your body thinks it's starving. This can also actually happen in real starving situations when there are people out there that haven't had food for a long time and have burned up a lot of their fat stores and their glycogen stores, their fatty acid stores, and now they are down to their own protein, their own protein mass. Now, eventually you're going to get to the point where you're going to have like nothing left and you're going to die because your body literally has nothing more to metabolize. So when you get to this state of protein metabolism, this is not healthy. This is dangerous. Using protein and converting it right to sugar is not dangerous, like me consuming, like, say, a protein bar, which isn't going to have a ton of carbs, but it's going to have a lot more protein. It will affect my blood sugar, and it will be converted to energy eventually. But it's slower process because of the fact of the way proteins are built. They're much more complex in the bonds they have to break. Keep in mind, they're folded on top of one another. They're stacked, they're folded, they're intertwined. They look like a spiral, depending on what type of protein it is. And if we need to use that protein source for energy, your body can do so from foods. But when you get to actually breaking protein down from a muscle mass or tissue, not healthy, very dangerous. Be very cautious of that. Probably what nearly killed me more in diabetic ketoacidosis. First of all, like the blood sugar. Second, off the ketones. But I think this probably would have killed me even quicker, because if you're wasting away so much protein and spilling so much protein out of your urine, that's not good, and that can start affecting your kidney health, starts affecting your microvascular health, and it just starts affecting your body altogether. So, like I said previously, this is your body's last resort for energy. Is protein from your tissues. Protein from food, yes, you can get it, but most of the time your body isn't going to use a lot of that protein, because if you're like most of us and eat any amount of carbohydrate, even Dr. Bernstein, even the littlest amount of carbohydrates that he eats, his body still burns that first. Then his body would burn the fat and then the protein. But you still have to cover for the protein because when it eventually does get digested, it will affect your blood sugars. But you still need to consume protein in your meals because, number one, if you absolutely have to go into protein metabolism, you're covered. But number two, you need protein to keep your cells healthy and for your body to repair your cells through the process of making DNA, or deoxyribose nucleic acid. So anyways, if you enjoyed all these series, I hope they made a lot of sense to you, and I hope it shed some light on actual metabolism through your body. I am not a perfect scientist. I am not a wholehearted expert on this, but this is knowledge that I've combined and I've learned and kept in my head for quite some time. This is knowledge I've refreshed myself on recently here, and this is what I've learned from research and all different other sources. So look these up for yourself, watch other YouTube videos. I'm sure there's other people that can explain this a little better. But I kind of wanted to do this just for fun and to kind of just maybe explain these more scientific things in an easier way for people to understand, because I know a lot of these things are super complex. So if you enjoyed this video and the whole entire metabolism series, give it a thumbs up. Feel free to hit that subscribe button down below. I post videos every single week about diabetes plus more. And until next week, 4 more videos. Take care. God bless. Be kind. Spread positivity. And be thankful. Bye, everyone.